So just picking up where we left off with that example, we'd found that the gradient of the curve at this point where x equals 3 is 4, so the gradient is 4. And then if we want to find the equation of that line, so that blue line, we use the point 3, 3 and the fact that the gradient is 4 to substitute into this mx plus c. So the gradient is 4, substitute in 3, 3, and we get c is 9. So what that means, sorry, negative 9. What that means is the equation of that line there is y equals 4x minus 9. Okay, and we can prove that to ourselves using the ClassPad. Firstly, we can go back and check using our tan line. So we wanted x squared minus 2x. Okay, so if we did tan line, interactive calculation line, tan line, we want that when x is 3. Okay, and it'll tell us it's 4x minus 9, which we got. And then if we want to have a look and see what that actually looks like, we can plot the original curve. Okay, so that's our original function. Plot the function of the tangent line, and then we can just fiddle with the scale a little bit. There we go. So you can see what we've got there is our original curve, our parabola, and then the straight line, which is the tangent to that curve at that point 3. Okay, so summary of this video, these couple of videos. The limiting chord theorem proves that our two-step, I should say our, not out, our two-step process for differentiation works for all polynomials, okay, which is very comforting. The derivative of the function is formally defined as this limit, okay, so the limit as h tends to 0 as f of x minus f of x plus h minus f of x over h, which is just a fancy way of saying it's the rise over run for some gap h, and it gets more accurate as h gets smaller and smaller. Okay, so this will give you the equation to calculate the gradient for any value of x. Then once you've got that, you can use the point gradient method to find the equation of the tangent. Now it can be a little bit confusing, particularly if you're differentiating parabolas, because, let's just go back here. This is your formula for the derivative, so this is a linear equation, and then you're actually working out another linear equation to get the equation for this straight line. They're not the same thing, and it can be easy to get those two mixed up because you're working with two linear equations. Okay, so you need to remember that this is the gradient of the curve, so the gradient of the parabola at any point, x, so gradient of parabola. And the reason it changes is obviously because the gradient of the parabola is changing. So it's negative here, comes down, stops. It'll be the 0 for an instant there at the turning point, and then starts increasing here. So at any point x. So once you've found that, you found the gradient at the point in which you're interested. So for us it was x equals 3, and now you're using that in a separate calculation. So this bit, this is like step 2, part B. This is separate. Okay, so just make sure that you're really clear about which linear equation you're talking about. Okay, also use your ClassPad. Okay, as I always recommend, do it by hand first, and then use your ClassPad to verify. It'll give you that practice in actually working your way around your ClassPad, and it'll also tell you whether you're getting it right when you're doing it by hand.